For millennia, we have gazed up at the stars and asked a profound yet simple question: are we alone? This query has echoed through human history, from ancient philosophers charting the heavens to modern astronomers peering through powerful telescopes. It has inspired countless stories, fueled our imagination, and driven our relentless quest for knowledge about the universe. The night sky, a vast and glittering tapestry of distant suns and galaxies, seems to whisper of infinite possibilities. With billions of galaxies, each containing billions of stars, it feels almost improbable that our small blue planet is the only place where life has taken root. This thought alone is enough to send a shiver down one's spine, a mix of awe and a deep-seated curiosity that defines our species. This fundamental question is no longer confined to the realms of philosophy or science fiction. It has become one of the most compelling drivers of modern scientific exploration. We are now living in an extraordinary age of discovery, where technology has finally caught up with our ambition. We send robotic explorers to distant worlds, analyze the light from exoplanets light years away, and listen for faint signals that might betray the presence of another intelligence. Each new discovery, whether it's a planet in the habitable zone of a distant star or organic molecules in a meteorite, brings us one step closer to an answer. The search for extraterrestrial life is a grand adventure, a cosmic detective story with the highest stakes imaginable. Our solar system is a place of incredible diversity and wonder. Beyond the rocky inner planets lies the domain of the gas giants, colossal worlds of swirling clouds and immense gravitational power. Jupiter, the undisputed king, is more massive than all the other planets combined. Saturn, with its magnificent system of rings, is a jewel of the night sky. These giants are fascinating in their own right, but it is their extensive families of moons that have captured our scientific imagination in recent decades. These are not just barren rocks. They are complex worlds with unique geologies, atmospheres, and histories. They are a new frontier, a collection of diverse laboratories for studying planetary science. Among this vast collection of over 200 moons, 2 have risen to prominence in the search for life. They are Europa, one of Jupiter's 4 large Galilean moons, and Enceladus, a small bright moon of Saturn. From a distance, they appear as little more than frozen, inactive balls of ice. They are bathed in the cold of deep space, far from the life-giving warmth of the sun that powers ecosystems on Earth. The key ingredient for life as we know it is liquid water. On Earth, life is found wherever there is water, from the boiling hot springs of Yellowstone to the freezing depths beneath Antarctic ice sheets. Water is a remarkable solvent, capable of dissolving and transporting the chemical compounds necessary for biological processes. For decades, this fact guided our search for habitable worlds, keeping our focus on the so-called habitable zone, where a planet's surface temperature would allow water to remain liquid. This was a logical, but ultimately limited perspective. We were looking for life in places that mirrored our own world, assuming that surface oceans were the only possibility. The revelations at Europa and Enceladus force us to look deeper, quite literally. The evidence strongly suggests that beneath their frozen exteriors lie vast, globe-spanning oceans of salty liquid water. To understand the secrets of Europa and Enceladus, we must first appreciate the most fundamental force in the cosmos: gravity. We often think of gravity as the force that keeps our feet on the ground, or holds the planets in their orbits around the sun. It is a constant, steady presence in our lives. But gravity is far more dynamic and powerful than that. It is a force that can bend light, warp the fabric of space-time, and crucially, stretch and deform entire worlds. So how exactly does gravity generate heat? Well, the secret lies not just in the strength of the gravitational pull, but in its variation. The orbits of these moons are not perfectly circular. They move closer, then farther away, in a repeating cosmic rhythm. This constant cycle of being stretched and relaxed generates an enormous amount of friction within the moon's interior. Think of it like repeatedly bending a metal paperclip back and forth. The same principle applies to these icy moons, but on a planetary scale. This discovery of tidal heating has fundamentally changed our perspective on where life might exist. For decades, scientists spoke of the habitable zone around a star. Europa and Enceladus have shattered this traditional view. Yet, thanks to tidal heating, they may be two of the most water-rich worlds in our solar system. This new concept dramatically expands the potential real estate for life in the universe. Our journey into the heart of Europa. When NASA's Galileo spacecraft arrived at the Jupiter system in the 1990s, it gave us our first detailed views of this enigmatic moon. Scientists expected to see a surface like our own moon. Instead, Galileo revealed something entirely different and far more exciting. Europa's face was surprisingly smooth and bright, with very few impact craters, meaning it is constantly being resurfaced and renewed from below, while the images of Europa's surface provided strong visual clues. Some of the most powerful evidence for its hidden ocean came from a completely different type of measurement. It was as if Europa itself was generating its own, weaker magnetic field in response to Jupiter's. The best, and perhaps only explanation, is the presence of a large, globe-spanning layer of electrically conductive fluid beneath the ice. The magnetic field data doesn't just tell us that there is a liquid layer, it strongly implies that this liquid is a salty ocean, much like the oceans we have here on Earth. However, observations from another powerful tool, the Hubble Space Telescope, have hinted at something truly spectacular. On several occasions, Hubble has detected what appear to be faint plumes of water vapor erupting from Europa's surface. If these plumes are real, they are a game-changer for future exploration. While Europa presented a tantalizing case for a hidden ocean, another, much smaller moon orbiting Saturn was about to steal the spotlight. When NASA's Cassini spacecraft arrived in the Saturn system in 2004, it made a series of baffling discoveries that quickly elevated this tiny moon to superstar status. The source of this activity was pinpointed to the moon's south polar region, crisscrossed by a series of long parallel fractures. Erupting from the tiger stripe fractures at the South Pole were colossal plumes of ice particles, water vapor, and simple organic compounds. With the discovery of the plumes, the Cassini mission's focus shifted. Cassini was about to become the first probe to directly taste the contents of an ocean from another world. The presence of organic molecules is incredibly exciting, as these are the fundamental building blocks of life as we know it. This provided the first direct evidence for active hydrothermal vents on the seafloor of Enceladus. The combination of liquid water, organic molecules, a source of energy from hydrothermal vents, and the presence of molecular hydrogen means that Enceladus has all three of the essential ingredients required for life as we know it. So we have found these incredible dynamic worlds, Europa and Enceladus, with vast liquid water oceans hidden beneath their icy shells. Astrobiologists generally agree on a core list of three essential ingredients. The first, as we have extensively discussed, is liquid water. The second crucial ingredient is a source of energy. The third and final ingredient is the right set of chemical elements, the building blocks of life itself. Therefore, when we look at the checklist for habitability, both Europa and Enceladus tick all the major boxes. To truly grasp the potential for life in these hidden oceans, we don't need to look to science fiction. We can look to the deepest, darkest corners of our own planet. Another compelling analog on Earth is found beneath the vast ice sheets of Antarctica. These ancient lakes, despite their extreme isolation, are teeming with microscopic life. It shows that a thick ice shell is not necessarily a barrier to life, but can instead act as a protective shield. While the environments of Europa and Enceladus appear habitable, the question of whether they are actually inhabited is the subject of intense scientific debate. On one side, there is the argument of cosmic abundance. On the other side of the debate are scientists who argue for the rarity of life. Ultimately, this is a debate that cannot be settled by theory alone. We have to go there and look. Our entire understanding of these distant icy worlds has been built upon the shoulders of robotic giants. The first of these pioneers was NASA's Galileo mission. A few years later, another pioneering mission, Cassini, arrived at Saturn. Together, these two legendary missions laid the essential groundwork, providing the tantalizing data that has made Europa and Enceladus the prime targets in our modern search for life. The groundbreaking discoveries of Galileo and Cassini have really paved the way for a new generation of missions. The first of these next-generation explorers is NASA's Europa Clipper. To achieve this, Clipper will carry a sophisticated suite of 9 scientific instruments. Over the course of its mission, these repeated flybys will allow Clipper to build up a high-resolution global map of Europa. If Clipper can fly through an active plume and analyze its contents, it could provide definitive answers about the ocean's chemistry and its potential to harbor life. While missions like Europa Clipper are set to revolutionize our understanding from orbit, the ultimate dream, honestly, is to get beneath the ice. These concepts, often called lander or cryobot missions, really represent the pinnacle of robotic exploration. The technological challenges of such a mission, y'all, are immense. Just imagine the moment we receive the first images from beneath Europa's ice, the very first glimpse of a landscape that's been hidden from sight for billions of years. Our journey through the outer solar system, from the fractured plains of Europa to the geysering poles of Enceladus, has profoundly reshaped our understanding of the cosmos and our place within it. This realization has opened up an entirely new category of celestial bodies in our search for life, the ocean world. For every gas giant we find, there could be multiple opportunities for hidden, habitable oceans to exist, dramatically multiplying the potential abodes for life across the cosmos. The journey from speculation to scientific certainty is a long one, paved with decades of meticulous observation, daring engineering, and patient analysis. Now we stand on the precipice of a new era of exploration, one that moves from broad reconnaissance to focused, detailed investigation. The search for life on Europa and Enceladus is not a single event, but a sustained campaign, a grand saga of exploration that will unfold over the coming decades. Our exploration of Europa and Enceladus is more than just a scientific exercise. It is a core part of our enduring quest to understand our own origins and our place in the universe. The question, "Are we alone?" is one of the most profound we can ask. Finding a second, independent genesis of life would change everything. The journey to Europa and Enceladus is a journey to the very heart of what it means to be a curious species in a vast and mysterious universe. And it is a journey that has only just begun.